IT consultant at Petrobras. Renzo, over to you.
Hello, good morning, good afternoon to everybody. Thank you, Adam, to the warm reception, the warm welcome. It's a great pleasure to be here moderating this panel, Panel 1, the progress of a hybrid digital twin for the downstream sector, effectively measuring the impact of prescriptive and predictive maintenance. I hope we have a great time here. Let's start with a short presentation of the panelists. I'm going to ask to Juan Pedro to introduce himself.
Yes, hello. Hello, everyone. Good morning, good afternoon. My name is Juan Pedro. I'm an industrial engineer. I have a master's in technology and business and a master's in data science. I work at Repsol, here based in Spain. I work as a reservoir engineer, as a well testing, and I'm part of technical authority group for engineering as well. Today, I manage implementation of digital transformation solutions at the upstream business, but in particular, I lead projects related to data, analytics, business processes, and also digital twins.
Okay, thank you, Juan Pedro. Mohammed, please could you introduce yourself?
Yeah, sure. Thank you. Good morning, good afternoon, all of the participants who are connected from different part of the world. This is Muhammad Zeeshan Anwar, and I'm very glad to be here as part of this panelist group. So expecting a lot of things which might be useful for us as well as learning for others who are as a participant. And background, I'm a chemical engineer working as a energy and sustainability specialist in SABIC corporate. So today I'm very energetic, especially to learn about the digitalization. Actually, we are driving a lot of initiative in digitalization, and would like to share also some information what we need to look when we talk about the sustainability and the digitalization. Thank you.
Okay, thank you, Mohammed. Shane, please, could you?
Yes, good morning, and thank you for having me on the panel. It's great to be here. So my name is McArdle. I work for Kongsberg Digital, based in Norway, and I head up what we call the digital energy division. So we are a digital twin company. So we build, develop, and deploy digital twins into different parts of the heavy asset industry. It's very exciting to be working for Kongsberg right now today, because the adoption and the pace and acceleration of digitalization has really just skyrocketed over the last year or 2 years. So 5 years ago, when this was being talked about as a kind of early technology, we see implemented and we see the value being returned very much so now in recent times. So I'm very keen to share and discuss with the other participants on this panel, and hopefully I can share a little bit of the experience that we've had over the last couple of years as well.
Great, thanks Shane for being here with us. And Horia.
Good morning. Here is Horia Orenstein. I'm a VP for Business Development at Lummus Digital. Lummus Digital is a joint venture between the reputed Lummus Technology and the reputed TCG Digital. We marry deep engineering and operational knowledge in the downstream area with very high profiled and cutting edge AI technology and platforms, end-to-end platforms for big data processing. And our topics, major topics, which are primarily discussed here in this very esteemed event is, of course, digital transformation as a part of the green digital transformation going on now. And we are dealing with digital twins, the functional hybrid digital twins, which we see is a key ingredient in order to succeed in this industry in the digital transformation. To my side, I would say I have 35 years of experience, hands-on experience in the industry in creating and operationalizing digital solutions. And also as a business advisor, I've been always during these years marrying, the business with digitalization. I wanted to thank particularly the organizer, but for this esteemed event, but also the support of Lummus Digital and TCG Digital, which has been given to contribute to this event. Thank you.
Thank you, Horia. Thank you, everybody. And me, myself, I'm Renzo. I'm a computer engineer with a master's degree in informatics. I started at Petrobras in 2006. And since 2019, I'm at the team responsible for Petrobras' journey to the public cloud, contributing to our company's digital transformation. I'm currently at the role of IT consultant for cloud infrastructure and hope we all enjoy the next hour and hope we have a great time with such a distinct group. And it's for me a great pleasure to be here moderating this discussion. So let's start it. Let's go to it. Let's start with challenges. Identifying challenges associated with digital twin, the importance of accurate data with Juan Pedro. So Juan, a digital twin model is as accurate as the data it is modeled from. So what is the biggest challenge to implement an advanced analytics model?
Yeah, thank you, Renzo, for the question. Actually, yes, when doing creating a model, actually digital twin based on model and using analytics as well, advanced analytics, one of the important things to have in mind is that initially people think that big data is because we have big data, we have the tendency to convince ourselves that the findings based on such a large scale of data must be accurate. But however, data quality is not taken into account. And if it is not taken into account, this assumption might be not true. Data quality is the one criterion for the accuracy of measuring or predicting something. To tackle statistical accuracy based on data and determining how well we can predict something, we need to ensure that we are addressing this concept, no? And one of the things to have in mind is that the data quality depends on the purpose of the use. And some guidance that we can have in order to ensure that we are addressing the data quality is ensuring that we have data free of biases, have statistical representative sizes, and very important, we document information. But let me give you three. I think that there are three main considerations that we have to consider when we are designing a data model, no, and actually ensuring that we are not building a data twin that is working with accurate data. The first one, I think it's, so I'm going to mention three. The first one is going to be design considering data standardization. Today, when designing a data model, we need to ensure data traceability, data observability, and consider maybe the use of data warehouse. I mean, all the metadata that we include in our dataset is a must. It helps the security, quality, and the transparency. So this standard design should have in mind that the beginning on how we integrate legacy systems. So I'm sorry, what I'm saying is, when we're creating this standard design, we should consider also that we have legacy systems and we should include those legacy systems. And let me say that one of the main things that we consider is we should integrate and not migrate the legacy systems, because migration could be quite expensive. Another concept, the first one we design and consider the data standardization, and the second one we building data models that are based on value first, business value first. Do not lose track on the business value. Ensure that data programs, I mean the data engineers, everything that you are building, this data, this digital twin, is not focused only in accuracy, but also focus, and actually mainly focus on the business objective, and so solving those business problems. Because one way to guarantee value is to break the silos between the disciplines. So, for example, if everyone add and understand that there should not be silos, everyone will add their best of data and also the best of knowledge. And the third milestone, I think that it's the third key element that I think that is important. It's analytics is not the new physics. We have been testing our technology, our fundamentals, our physics for more than, let's say, 100 years. Our refineries and the upstream business have been working for more than 100 years. So it's a misconception considering that advanced analytics is a replacement for the physics. It's actually a tool that will help us to leverage from the previous, leverage from our experts. We have experts in the house. We have models that are already working, so we should use these models to leverage. So, in conclusion, 3 key concepts: design considering data standardization, ensure that we have business value first, and last, analytics is not the new physics.
Yeah, very interesting, Juan Pedro, what you said. We usually think of the amount of data that we have and what we are gonna do with the data, but we usually don't think the next step, the quality of data. You highlighted this very interesting point. And the other point I took note here is the integration versus migration. And indeed, if you try to migrate to update legacy systems, maybe you're gonna have to put a huge effort and maybe having not the proper results that you would expect. So very interesting point of view of integration. So what to do if you do not have yet the proper information to build the models? We are talking about this quality of data. What to do if we don't have data with the proper quality?
Yeah, that's a very good question, actually. And I think that, to be honest, you will never have everything aligned to build your model. You will never have all the information on hand in order to build whatever you need. Actually, it requires a lot of work, and again, not only as you mentioned, not only because we have legacy systems, but also because maybe you need to align also the teams. Building a digital twin, building analytic models is not only about the technology; it's also about the people. So you have to ensure that you have that on hand. And also we have to consider that you have to build whatever you have, whatever you are able to make. What I mean is, models should be used for what is very viable. Do not stretch data for more what it's capable of. Maybe over extrapolating could result in failures and loss of confidence from the business. So my conclusion would be, even if you think that you don't have the proper data, for sure you have something. The only thing that is be conscious and not overpromise.
Okay, as I can see, starting with anything is better than not starting at all.
Yes, agree, 100%.
Great. It's a great point of view. Does anyone would like to complement something? Muhammad, Shane, Horia?
Yeah, I would like to reflect on that. I think, as John mentioned rightly, the data quality is a real challenge, which I think we need to address in upcoming time, maybe, because if we don't have the data quality, and the data availability also important with the same intensity what we are talking about the data quality, because the machine what we want to develop, a kind of the virtual machine or the any model, it would not work out, right, if the data quality is not behind that. We can produce a machine of any quality based on the data, but the outcome of that machine would be according to the data input quality. So that's I think critical part in digitalization we need to address. So the data quality, the first priority, and the second thing is the data availability, because in the manufacturing of the downstream plants and even the upstream oil and gas industry, they have very old assets, maybe built up maybe 50 years or maybe more than that year ago. So real challenge that we don't have the instrumentation as it should be as of now. We are demanding for the digitalization. So that's also a critical piece of I think equation need to address. I mean the availability of the instrumentation for the required, the data availability. And the third point, I may reflect on that also regarding the unavailability of the data, what can be done. So there could be the synthetic data can be generated, but again, that data needs to be developed by a systematic way, which is acceptable by the machine and the people who are working on that machine. So that's again, I think, critical for developing the new data for the machine learning, which might be a future challenge you need to address. Thank you.
Thank you very
Just go
much,
on.
Muhammad. Yep.
Thank you. I think that's a very, very good insight from both people. It's a very practical insight because, Renzo, we've all bought into this prevailing zeitgeist of AI. It will solve everything, and having more data will make things easier. And it's funny. I remember a quote by Gartner a few years ago that predicted that by 2022, which is this year, 85% of AI projects would fail due to biases in the data, algorithms, or even the people managing said data and algorithms. And I think that's a very, I would imagine, I haven't measured this or I haven't seen how it's been measured, but I would imagine it's very, very close to that prediction today. Industrial data is complex. And when you're talking about scaling analytics or data science across an industrial facility, it's not the same as using consumer data. And I think Mohammed alluded to this very well, saying that we don't always have the data, or we don't always have the relevant data to build the data sets. We don't have the events to be able to do some predictions. And that's a big challenge for us because people say data is cheap. That's not true. Data is actually quite expensive. If you want to get relevant data sets, it means you have to perturb or change your system to get the data that you require. And that could mean shutting down a piece of a facility. It could mean, driving that facility into unfavorable operating envelope in order to get that data. And that comes at a price. And just to follow up again on what Mohammed was saying, and also tie it back to Juan Pedro, physics-based models or first principle models are the closest you're going to get to reality. It's been built on for hundreds of years, mathematical formulas. And if you can combine this, and this is the hybrid machine learning approach or hybrid model approach, which I really believe is the only way we're going to solve scaling AI in our industry. If you combine this in the correct manner, you will be able to have that good, clean, synthetic data built on physics, known models, to augment what you're already collecting from your facility. And this leads back to that point Juan Pedro made. You always have data, and if you don't, you can have a synthetic model that will actually provide you that data to get started. So I think two very practical points made by Mohammed and Juan Pedro here.
Yeah, data that leads to good information is expensive. Some people say it is the new petroleum. Yeah, definitely. So Shane, let's continue with you. Let's talk about self-optimizing facility, how to make AI work safely and reliably with domain expertise, and how to simulate and select optional asset development and operational scenarios in real time. So I would talk about domain expertise, the importance of digital solutions specialized for the downstream sector. We were just saying that we are a very particular sector, domain of knowledge. So please highlight the importance of partners that have the proper expertise on downstream sector and how to go from this point on.
A lot to unpack there, but starting let's say at the start, I suppose I've been in this industry a long time, and a lot of my colleagues have been in industry as long as me and longer even. And we're all very aware that running a profitable and efficient downstream business, it's very demanding. We're constantly challenged to recover underperforming assets, avoid unplanned shutdowns. You have to pivot, do cutovers when market condition changes. And we have this now prevailing energy transition pressure, these environmental regulations that are very stringent, also bearing down on the downstream industry. And when you're thinking about integrating a digital operations strategy on top of all of that, it's very challenging, and it requires not just sustainable change from a technology point of view, but it's also behavior. We need to create this culture of innovation, but we also need to reduce the barrier in the workforce digital competencies in parallel. That's very important, because the domain expertise part really plays into the codification or industrial software / AI piece. They go hand in hand. And if you can make it easier, if you have mature digital technology that scales out of the box, this helps that adoption. It does not need to be perfect, that's for sure, because digitalization is about a forward journey, but it needs to be proven, and it needs to focus on user empathy. And what I mean by user empathy is, the ability for different levels of users to be able to adopt the technology and generate insights out of it. I'm a big believer. I know AI has been proving itself for a while, and machine learning, but I'm a big believer that data analytics is going to have a massive impact on our industry. It's already proving its ability to provide predictive insights, especially on predictive maintenance. This is a very much, I would say, an established digital solution. But why that has been the case is, first of all, it's been a lot of good sensor data associated with it, but also a lot of the OEM vendors that have been working on it have the domain experience of that piece of equipment. So if you are to provide effective insights into our industry, into our processes, into our equipment, domain expertise remains the key. You need to bring them into the conversation. I mentioned about industrial data being complex, and that we have a lot of dark data and bad data. Dark data is that data that we collect, we process, and we store, but we never use. And that happens all the time because of our siloed systems. Bad data is something different, and bad data is data that we collect, but it's unusable. So if you think of a faulty transmitter or a stuck valve, it's still producing that data. It's just very much unusable. And we need to be cognizant of the fact that we need to solve for that. We need to solve despite bad and dark data. And this is why I think hybrid modeling approach is the only way we're going to solve this, at least in our industry. Data science without access to domain experience, what you end up with is a lack of understanding of the data and how it fits into the operational setting. So what's the result of that? You get bad models, and people go, oh, I give up, we tried it, it failed, it didn't work. But it's just because we didn't take the right approach. Or you end up with extremely slow model building. So a data scientist with no understanding spends a long time iterating, and going through several different variations of maybe a model, because they just don't have that understanding of what they're trying to solve. So that's a big challenge. The second challenge is demand for experts in modeling. These processes are very scarce. They exceed the supply. So talk about a very, very difficult supply chain problem. So again, hybrid models combine AI, first principles, deliver a nice, comprehensive and accurate model without requiring significant expertise. And you can also scale it quite quickly across an organization and into an organization that doesn't necessarily have to be experts. When I look at wide scale adoption across a facility, so plant-wide modeling for optimization. If we look at the pure physics models, and they exist today, but those have been implemented as a huge project. They've taken years to build up, develop, then to keep alive and keep fresh and keep updated. It's a big and heavy manumatic job to do that. So those models are difficult to build, and they're not very scalable. But reduced order models, where you use synthetic data to power data models, and I think this is what Juan Pedro alluded to, Analytics is not replacing physics, but together they're very, very powerful, because what you can do is you can abstract those heavy models to an enterprise view, which then can inform executive awareness. You can make better and more agile strategic decision making, and they run faster and they run more intuitively to drive more agile decision making. They're more based on scenarios analysis rather than just like heavy analytics that we call letterbox analytics back in the day. You know, someone puts in a request for an analysis and 3 weeks later you get a result. That's not real time. It doesn't really help you in your day-to-day operations. You also have this better sustainability and robustness of your model, because since hybrid models are both data-driven and first principles, they're very closely tied to the plant data, and they're able to keep in sync with the assets, closely evolving and calibrating against the plant, and therefore able to sustain the benefits of modeling more than just a pure first principle modeling. So that's also very, very important if you're looking at wide-scale adoption of this technology. We've had, and I don't like pointing fingers at failures, but let's look at another industry, and I think it's widely documented, but this IBM Watson for the medical industry, this failed because they didn't take into consideration these secondary constraints. So if you don't take in these secondary constraints and build them into the analytical processing from the start, the algorithms just don't work. And again, hybrid modeling backfills those constraints very, very well. So you can probably hear from me. I'm a big believer in this. I feel we're scratching the surface. We haven't really driven this at scale yet, but I think it's the only way we're going to solve it, at least from our industry perspective.
Very, very interesting, Shane. I've noticed that you mentioned that even if we don't have the perfect model, but it's important that we have a proven model. And I think it connects perfectly with what Juan Pedro started saying, that even if we don't have the whole amount of data that we desired, let's start with the data that we have. And I think it connects. Very interesting. Thank you. I would remind to our audience here that if you have any questions, I'm with an eye on the chat, so you can write there. I'll be trying to pick your questions and bring here to the group to be answered. Any other considerations? Horia, Mohammed, Juan Pedro?
I would like to intervene and to actually support what Shane was saying concerning the hybrid digital twin. That's something we in Lummus Digital are also following up. Actually, the twin, and that's actually an expression of the knowledge. And I just wanted to add that aspect. The knowledge, it's a very important, it's a formalization, digital formalization of the knowledge. And that's why it's so important, that hybrid is important, because you have on one hand the first principle theory, which is in quotes just years and the generations of theory accumulated, we can't ignore, and you marry this with analytic data brings the touch of reality into the very important concept. And also what Shane was touching upon is actual insights. Insights are information, and that's the actual bridge between the data, which has been mentioned before, and the knowledge. Yeah. So the information, the insights, we call that 360 degrees instantaneous insights. That's the holy grail today in order to become actionable. I just wanted to mention that.
Great. We have a question from Dmitry Rodinov, a question to Shane. Shane, Dmitry is asking, what are those secondary constraints that you mentioned?
Yeah. So in a lot of cases, as I said, when you start the data is the most important piece of any data model. You know, you have to start right. Then you look at the 4 V's: volume, how much of the data; variety, what kind of data; velocity, it's the frequency, it's real time; and veracity. Now, veracity is the significance and reliability. So those secondary, I think that's the most important, and that's where the secondary constraints come into it. For data to be useful, collection needs to come from reliable sources. What we saw in, let's say, in the medical industry was it wasn't coming from the most reliable sources. It didn't integrate the domain expertise into the process. So there was, I would say, an unconscious bias built into it. That wasn't the right bias. Biases can be good sometimes. The processing methods need to be considered. They need to be relevant. The analysis for reporting and prediction purposes needs to be in context. So contextualized data is extremely important, not only for the data and model building, but also for how you present the results. And I think that's really key, that data contextualization piece. Long time ago, I used to build data models, and it wasn't just about having the real-time data. I needed the vendor equipment diagrams, I needed the P&IDs, I needed control narratives, and finding all of this data was very time consuming. You know, you had to go to multiple sources, ask different people. And I think it was one Pedro mentioned, integrate, don't migrate. But the core principle of a digital twin is that digital integration. It's just picking up the information from SAP, from your business transactional data, from your real-time series data, from your document management systems, and you're able to just put it all into one location and start with already access to that data. It's a huge job collecting the data. I can't remember, there's a lot of quotes out there, you know, but 70 to 80% of the time is spent on collecting the relevant data. And then you have to make sense of it. And that's a data contextualization piece. If it's put in context with one piece of data and another piece of data, you're off to a great start. And then when you build a model, it enriches the data set you already have. You have to put that in context that gives meaning to people, because not everyone's an expert. Not everyone understands what an R squared number is, you know? So you need to just take that and make it a little bit simpler, put it in context with data or information that other users are familiar with, so that it enriches their job, not makes it more difficult or makes it, oh, that's just another number, I'm just going to ignore it, but actually enriches their job and gives them some support to make better or smarter decisions. So those secondary constraints, they're a little bit broad, but I think it starts with the digital contextualization piece and the veracity of the data.
Okay, thank you so much, Shane, for the explanation. Thank you, Dimitri, for being here with us and for the question. Let's move on. So let's talk about transition. I think transition is a hot topic of current times, ever-changing operating conditions. We are speaking of an environment, our sector, that is suffering, that is facing significant changes. So, Horia, about changes, imperatives for a transition from a liquid market maximum throughput to a custom product volatile demand. What could you tell about us about this?
Thank you for asking this question, which brings actually what the technical stuff we were discussing to the other end of the discussion, which how does this help the industry? So probably everyone expects fundamental and unprecedented market changes in the downstream sector by 2035 and 2050. All signs are about, the fact that the demand for fossil fuels is vanishing. Crude will be replaced by recycling feedstock. There will be a high competition on the petrochemicals and chemicals, and we will see more custom formulation, which short product life cycle and high quality demands. This will happen irrespectively of temporary disruptions like the war in Ukraine, or these events might even accelerate, the trend. The pressure by the global policy and the society for a green digital transformation is huge, and it might be fair to say it cannot be ignored anymore. And this means for asset owners and operators in downstream ever-changing operating conditions combined with ever new requirements for continuous asset transformation. On the digital part of the needed transformation, we see that on one hand, there are so many information to be processed fast and for reliable decisions. This cannot be done without smart digital assistance from functional hybrid digital twins. On the other hand, there is no human experience for the complex coming market and operational scenarios. The industry needs frequent simulation of multiple scenarios and to pick up, the decision for the best of those scenarios. And this also requires AI assistance and very solid and resilient and fast functional hybrid digital twins.
Okay, thank you, Horia. And about the ever-changing operating conditions, how can plant planners and operators build a smart refinery integrating AI and machine learning on your vision?
That's a very, strategic strike into the business. I would respond that this is possible through changing the paradigm of doing business from the ground. The first major paradigm change which is needed is to make the big data processing as a backbone of the whole transformational and operative business activity. Here, you better include the corporate digital knowledge, the digital twins, as a corporate asset, playing the digital assistant and the digital trainer role, as well as the AI-assisted simulation of many virtual scenarios for a proper decision making. Today, the backbone of the business activity, operational and project, it's a quite rigid and siloed domain-oriented hierarchy with a rigid procedural framework. So here we see the difference on the way we have to go in this industry. The second major paradigm change is, in our opinion, is the introduction of the loop of continuous improvement in form of an integrated planning, development, adjustment continuum for all transformational and operative business tasks, especially for the most critical ones. Today, planning and deployment are separated, and each domain has its own plan and its own separate deployment. It is clear that plans are, under such circumstances, less relevant and trusted, and adjusting navigation through deployment surprises is more of a local art than a generic science. Our expertise in Lummus Digital is the digital formalization of knowledge in functional hybrid digital twins. And we see this as one of the most critical success factors in digital transformation because they represent the best integrated virtual replica of any variant of the past, of the present, and of the future reality. They show the way how industrial and business processes truly work. That's the functional attribute. Unlike static digital twins coming from the 3D world, which give a sense of how assets are built, the functional hybrid digital twins are highly dynamic and the true enablers of multiple scenario simulation, also in real time when needed. Unifying the engineering and operational theory with historic facts, they are fast to build and truly accurate. That's the hybrid attribute.
Very, very good, very interesting points, Horia. Thank you. I would like to highlight a comment here in the chat. Joseph Knudson said, adding to Shane's point, once you have all the data in one place, more value is automatically created too. Suddenly you have visuals on the location of any kind of data, e.g., where a maintenance job needs to be performed. Very well observed. And Parag Patil is asking, as far as small companies are concerned, how would they start in digital twin, as it may require costly hardware? He's worried about the cost of hardware. Could anyone help us on this?
Well,
I can
if I
start.
might jump
Please,
in.
Horia.
Okay.
Please,
You know,
you start before me.
yeah, today we have the cloud, right? So, you know, it's useless to say that, you know, based on the needs and the use, you know, you have a very flexible way of, you know, operating with big data today. That's a short answer to that question. If anyone wants to add to that, gladly.
I think you're right that this is an essential part of what we do around digitalization. But you know, last couple of years now, we've worked with all levels of data maturity of different types of assets. We work with like 100-year-old refineries. We work with like 4-year-old gas processing plants, and you can always start. You know, today you're not operating your facility blind. You have some maintenance information. You have some sensors. It may be siloed, but you're still able to get access to that data. That's what, at least from a digital twin, it integrates all to these data sources and it puts them in context with each other. It doesn't have to be a very advanced database system. We took a hard drive from one facility with 1 million scanned PNIDs. We were able to make them smart. You know, so there's a lot of really good technology and innovation already done on quite, I would say, data immature facilities. I mean, you're going to be able to say get pervasive autonomous asset. It doesn't mean you get all the way there, but you'll definitely get 1, 2, 3 steps up the ladder towards your digital journey. So I've heard this so many times. We're too immature. We don't have the right enough data to start a digital project, and it's not true. You just have to temper your expectations, but there's still a lot of low-hanging fruit available for these type of facilities, and I've seen it again and again.
And if I may add to Jane's point, most of the refineries that we have today and most of the upstream also facilities are prior the digital era. So no, every single company has the same issue, and every single company was able to start with something. So you don't have to think that you need to be in the peak of the technology in order to start building a digital twin or a digital solution for your asset. Because again, everyone was in the same position a few years back.
Great. Thank you, Juan Pedro, Horia, Shane. Parag mentioned here, not about the data transfer, etc., but about modeling the real systems. Small companies cannot afford it. I would take this extra comment, and I would drive the discussion to Mohammed. Let's talk about sustainability costs and how to successfully survey environmental impacts. So, Mohammed, please help us on understand this point, the contribution of digital twin for sustainability in downstream and for the environment as a whole. Thinking that prescriptive and predictive maintenance mean more efficient production plants, less residues, and less pollutant gas emissions. And I would like to connect with these concerns about costs. What could you tell us about that?
Right. Thank you. Thank you, Renzo. I think after the Paris Accord, so it's now getting a more important, especially in petrochemical and oil and gas industry. Sustainability is one of the biggest challenge we need to address is in the upcoming time, maybe next 2 to 3 decades till 2025, 2050. So in the industry perspective, if we look how much emissions globally we have due to the industry, I think it's now 145 billion cubic meter yearly we are emitting emissions in the form of gas into atmosphere, which is ultimately ending up into the climate change. So that's very important for the industry to address it. I think in the digitalization perspective, if we look that it can assist immensely to reduce these emissions, if not the zero, because when we define the industry, we define it to 4 categories of this industry parts. Like for any layman, it can be like feed preparation. Then we heat the process streams, or we convert them into through the reactor, and then we quench it and cool it with the cooling water, and then we separate the desired product out of this process, and then we sell it. So in these 4 segments of the process of any petrochemical industry or oil and gas industry, we see that there is a huge potential of the losses in the form of feed or molecules up into the sometimes environment, and that's important also to end up for the safety of the people who are working around that facility and to depressurize in case of emergency happening. So if we talk about the emissions that ending up due to the this upset in the plants, how can we address through the digitalization? I think although we are in the nascent stage of the digitalization for the petrochemical industry, might be in the numeric sense, it's quite advanced. But when it comes to the applying the digital solution on the engineering science, it's still a challenge for us, right, to adopt it and to accept it up to the desired level of the readiness. So in that perspective, if we want to reduce the emissions, especially in the operational upset or operation, could be the startup or could be the emergency handling during the normal operation, we need to have the kind of the algorithm to drive the information which is useful for the operators. So human interface is very important for us to minimize the emissions. But if we provide the digital solution with the human interface to control the assets in case of emergency or any safety incident, to control the safety incident and also the emissions, so that can play I think a pivotal role to reduce the emissions. So how can we achieve it with the digitalization? I think it's a different approach can be adopted, because as I mentioned earlier, the readiness of these solutions, digital solution for the industry, is at not the desired level. It has to emerge a lot to reach to the desired level and of acceptance. And when we have this solution in future, for example, if we can define the solution for the operational emissions and could be the non-operational emissions. If we talk about the operational emissions, like in a simple scenario, if we are running any complex integrated site, and we see that during the summer days there is the change in the cooling water conditions, right? And that cooling water condition is going to affect on your production, and the unreacted component is going to be flayed because of the less condensing or separation or rectification of your final product, right? So that's maybe ending up into the atmosphere. But if you have a digital solution, integrated solution to distribute the cooling water system across the 4 major section of the plant or maybe the complex, that you can compromise somewhere and put more, the cooling duty somewhere where you are expecting it's going to be impact on the emission side. That can be kind of the opportunity. We can develop the model and can leverage on the digitalization. But as I mentioned earlier, the digitalization is required a lot of data, a lot of accuracy acceptable, for the human interface who are dealing with those equipment. That's still challenge, but I believe this can be addressed. But in addition to that, I think there is still a lot of efforts needed to intervene with the human interface, working on this panel operator side, especially the human intelligence, how we can grab those intelligence, the action they take on day-to-day basis to control the emissions, and then we translate into the data analytics in the form of the advisory solutions. For example, if we take any heating furnace we are using in the industry, right? And someone is very expert panel operator supervisor. When he takes startup and he takes in case of a shutdown emergency, he managed very well and safely shut down and safely start up with minimum emissions into the atmosphere. But the other guys, maybe he's new in the team, he's not up to that level of the maturity or maybe expertise. He needs some advisory tool, and digitalization can help here in some way. I would say that maybe in such a way that if we are mapping the events of history of that equipment during a startup and shutdown and link it to the process parameter, what you need to do, and if you don't do, what it's going to be consequently impacting on your asset performance as well as on your emissions, that can help a lot for the preserving of human intelligence, especially for the industry. And that area I think we need to maybe explore more by the solution provider. And also we maybe as a solution user, we need to have a look more inside that how can we leverage the human intelligence also along with the data science. So like about the predictive maintenance, I think it's also a very interesting topic. I mean, the predictive maintenance can also be determined before the failure happened with the digitalization, and it again is driven from the equipment information available we have. Like for example, if we have compressor, we have a lot of instrumentation available, which might be not being used, as Sean rightly mentioned that there is some dark data. So if we utilize those data and predict the equipment health, and that can help a lot, especially when we talk about the failure happened due to the equipment failure, or maybe shutdown happened due to the equipment failure. So for those critical equipment, we can have kind of solutions which can help us to define, maybe redefine the preventive maintenance cycle of that critical equipment, and to avoid unknown, desired situation, which is the complete failure. That's my reflection. I think there, as I mentioned earlier, the readiness of the digitalization, maybe for the petrochemical industry, is required a lot to do, especially to come up with the more acceptable solutions with the highest level of readiness, somewhere 9 to 10, so that people can adopt. And maybe if we reach to that level of readiness, I think might be we will start forgetting the engineering equations, first principle equations. We just maybe talk about a different type of model, just plug the data, get the result out. So that we also need to preserve somehow the engineering science data behind that. And I think hybrid approach would stay there. We should use the hybrid approach again to validate those models, so that we can have highest level of the confidence when we go for the industrial solution deployment. Thank you.
Okay, thank you, Mohammed. Very interesting points. Like I said, I'm with an eye on the chat, and Parag, he added a very interesting point. He thinks that an example of digitalization to reduce emissions would be use of digital twins to decide precisely when to do maintenance of an equipment. This would help to stop energy wastage. I think Parag got the question from the very, very center. We have some minutes, some final minutes for questions. And I would like to drive the discussion now, at least take a time for this point, because so far we have considered technology, data, machines, solutions, and quality of results that we are pursuing. But Ali Kashi brought to discussion a very interesting point. We should consider the human factor of all that we are speaking, and this is the reason why we are here. There are human operating these systems or using the results of the solutions that we are speaking of here. And he says, speaking of paradigm shift, how challenging is obtaining buy-in from the human operators on the ground for a digital twin. I have some things that I would consider. I think it would facilitate their jobs, and this is a very good reason for them to joining. But I would like to hear from the group here how to bring the human operators to these initiatives that we are discussing here. Are they gonna lose their jobs?
Right. I would like to comment on that, and that's a very long experience of implementing digital solutions over since IT exists. People are fearing that they might lose their jobs, and look around. It's not less jobs around. We have much more jobs, and these are more interesting. But now, in the context of this fundamental change standing in front of us, what I believe it is essential is actually to take what we call as a digital assistance. So it's not the digital doesn't replace the human. It's amazing. Acts as an assistant, a partner to everything the people are doing. And once they realize that, and this is truly the experience I had in many years of implementing projects, is once they realize that the assistance is of use, and the performance gets better, and he shines. The guy on the floor shines. That's a won battle.
Horia, I think that's spot on, and Mohammed, just to allude as well. There's a sense of purpose. There's a sense of purpose, especially around this green energy shift, right? And you can talk to pretty much anyone on a factory floor, going, yeah, I want to contribute to that, but I'm so busy with my day-to-day work. And there's a report. It was Frost and Sullivan that were talking about Industry 4.0 being cold and being more tech central, and it's intimidating workers on a factory floor. But this next phase, this Industry 5.0, is really talking about bringing back and empowered humans to the factory floor. And Mohammed, you had a couple of really good and interesting analogies inside there around sustainable digitalization, the transition and sustainability, and how hybrid models approach into that. And I give you two very simple examples of where we've impacted on sustainability side of things, where we've used hybrid models, and where the workers have been really, really happy and have adopted this very quickly. One work process or business process in a downstream industry, and in a lot of industries actually, is called flange management. And it's where you have two pipes joined together, in a circle, and you have all the bolts that go around, and you have to make sure that they're secured correctly. Now, there are thousands and thousands of these flanges in a normal facility, and this work is carried out. It's a critical piece of work that's carried out, every single year, every week. 30% of all emissions in a gas processing facility, 30% of emissions are due to faulty flange management. That's a huge amount, right? So through the use of digitalizing a workflow here, we were able to address faulty flange management and really take a dig into and remove some of those emissions that are happening. So first of all, you're hitting the emissions. You're hitting the green shift piece, and so you're as a worker, you're really happy about that. And secondly, you still need people to physically do this. That's not going to change. Robots are a long way away before they can do this job. So you still need a worker there, but it enables them to do the work better, and they're more confident that the work is done, because you're able to see this inside the twin, that this piece of work has been done correctly, and they can walk away with that confidence. And a lot of the information is already uploaded and done automatically inside the twin for them. So they were super happy about this. Very simple process, but a very impactful process. Next of all is something called isolation planning that we're working with. I'm not sure if you're familiar with isolation planning, but again, another piece of critical work where you have to, if you want to work over a piece of equipment, you have to plan how you're going to isolate it, you have to drain it, depressurize it, etc. I've done this 20 years ago, and it's probably done the exact same way today. You have to collect all the information, you have to mark them up, you have to identify all the areas on your diagrams, you have to do lockout, tagout. It's 2 to 3 days of work. We have a lot of maintenance engineers working in-house, and we put them together with some developers. And within a couple of months, we had a semi-autonomous workflow to do the isolation planning that also included some soft sensors or hybrid models to identify some missing pieces of data. So this worked really well, and now we're actually going to come out with a fully autonomous isolation planning workflow inside the twin. You think those workers are happy to sit around for 2 to 3 days just collecting that data and doing all of this work? They're not. No one's happy. I wasn't happy doing it. I wanted to do my piece of work. It was time on tools I was interested in. And again, we're already seeing them so interested when we engaged with one operator just to test this and pilot it, and they keep coming back with more and more, and they're the ones pushing for full autonomy. So this was a really successful, I would say, adoption of a digital tool within the industry without removing people. It really empowered and augmented people, and that was very, very exciting. And I love that's the part of seeing the user adoption and the happiness and the well-being increase around the adoption of digital technology. So that was just to extend a little bit on what Mohammed and Horia mentioned there.
Yeah, guys, I'm afraid we're running out of time. Certainly, we would have what to speak of for the whole day, or maybe more than one day. I think I have to thank Juan, Pedro, Muhammad, Shane, Horia, for this great time that we had here. I've learned so much. Thank you for your considerations, the information you brought to us. Thank you, the audience, the participants, for the questions, the insights, the points that you added to our discussion. It was also very important. And we're just beginning the conference. Certainly, we will have the opportunity to have many other very, very interesting discussions. So I would like to thank you all, wish a very good day, very good afternoon, and most of that, a very good event for everybody. Thank you all, guys.